All right. So like I said, we're still in chapter 4, wrapping up 4.4. We're still in objective 3, which is condensing them. If you're asked to condense, hopefully your first thing you do is you go, all right, well, the answer has to be log, and it have to have the same base. Where if there's not a base written, there's imaginary what? 10. Very good. Base 10. All right. So after that, what do I know about all coefficients? What do I know about all coefficients? How do they become a coefficient? What were they originally? Think about what, if we're going in reverse, when we expand it, things that became a coefficient were originally what? Not a root. The power. It was the exponent. So all these coefficients are the powers of all the guys inside their logarithms. Remember, you're going backwards. All right. So then I can kind of start writing it. This is going to be a C to the 15th power. And what does minus mean? Division. Then I have a D to the 1/4 power. But what do I do with this K? Should it be divided again? It'd be multiplied, because if you remember, this is the same thing as if I did negative log, sorry, 1/4 log, D plus 3/4 log K. All right. Where you just distribute that negative and you get to this point. So if you have two minuses, that just means everything that gets a minus is being divided at the very bottom. It's when you switch to a plus sign at that point, then it would be multiplied by that fraction. All right. So that just means that this K will be on the bottom. Now, if you do forget that, like maybe you're like, all right, well, I'll just divide this again by 3/4. If you don't know fractions already, when you're dividing, keep, change, flip. You keep it, change it to multiplication, flip that fraction. You end up multiplying both of them anyways to get your outcome. So you can get there that way as well, just in case you forget that little rule. Because technically that part can be written like this. But if you've forgotten, because it's a grouping. So if you forgot, you could, here's a little side, I don't know, what, keep up with me? Maybe. So if I rewrote this like this, and let's say I forgot, so I ended up, okay, so there, let's say that's a 4 there, pretend. There you go. And then let's say I forgot, and I'm like, all right, well, I'll just divide again, right? That's divide, divide, divide. Keep, change, flip. This is the same concept as then doing this. That's technically over 1 because that's a fraction in itself. How do you multiply fractions? Straight across, so you end up getting this point anyways. So even if you forget that can happen, you can still do the math and get to the same outcome. Right? Now, I'm okay on the test. You write it like this, that's 100% right there. On your homework, they're usually going to make you turn these rational exponents back into radicals, which again is exponent over index. Now, go ahead. No, it's multiplication, because remember, addition condensed down is multiplication, and multiplication expanded out is addition. So technically, yes. So technically, there is a multiplication sign right there. All right. Now, to be able to write this like what your homework's going to want to do, notice both of these have a denominator of 4. So this can be rewritten. Again, totally acceptable here, but I want to make sure your homework likes your answer as well. I can technically rewrite this as such. What do I do when I have a power outside the exponent? I would multiply. So 1/4 times 1 goes back to 1/4. 1/4 times 3 goes back to 3/4. So if the denominators are the same, I can pull that denominator out with the 1 on top, rewriting it like this. Now, 1/4 is how E over I. How's that written as a radical? What fourth root? Very good. So then your final result, most likely what your homework's going to want, is this guy right here. C over 50, C to the 15th over the 4th root of D times K to the third power. Again, totally acceptable here. Most likely what your homework was going to want. However, they might accept this as what's that, an alternative answer, whatever they give you. So they might take that. So you might not have to do all this work. But if they do, I want you to understand that as well. Questions on that? All right, let's do another one to make sure we got the condensing part down. So I think this is number 11. 1/4 log base 2 of W plus log base 2 of W squared minus 100 minus log base 2 of W plus 10. It's a 10. So take a whack at it, see what you can come up with. Interest rates. If you're interested in that, business calculus and going into the business world, be the business calculus not that bad. Sounds bad, but it's really just using formulas where you just plug in. The only thing that makes business calculus hard is knowing which formula to use at what time, which is what kind of like accounting is. Anybody, you already got an answer? No. Yes. Yeah, go ahead. You talking about the properties or whatnot? Yeah. A good flashcard. Remember, you got to know all 7 of those properties. So make sure you're studying them. No, there's 7. We did 4 and 4-3 and 3 and 4-4. So there's only 7 to know. And really, once you do it enough times, they start kind of making sense. And yeah. All right. So again, when you're condensing, what does it condense down to? How many logs? Just 1 log. Always start there. Base 2, because they all have to have the same base. What do we know about exponents? Or sorry, coefficients? They turn into exponents. So I circle them. I like to do it here just as some side work. So I get W to the 1/4. What's plus mean? Multiplication. So times W squared minus 100. What's a minus then mean? Then divide. All right, but there's more to this. What's special about that W squared minus 100? Huh? I wouldn't distribute. It's a perfect square. So how do I factor it? Good. It's a difference of squares. So you can rewrite this as W minus 10 times W plus 10 over W plus 10. And what's going to happen to that W plus 10? They cancel out, giving you now log base 2. Go ahead and rewrite this. How do I rewrite W to the 1/4? 4th root. And again, if you kept it as an exponent for me, I would accept it. But for your homework purposes, this is what it would probably want. And most likely, I guess proper written, you can use another set of parentheses or brackets indicating that all of that is inside the logarithm. Because if not, it just looks like this part's in the logarithm times this, and that's not the case. Okay. You could use parentheses or brackets. I don't mind. Nothing. It's just a different grouping symbol so that people don't get confused on so many parentheses. Yeah. Because you'll get into some maths where you'll have like 5 or 6 parentheses at the very end of your problem. You're like, how many? And then you're trying to count how many they need to end. Yeah. Heck, I've even seen people use the squiggly brackets with inside their problem just to help separate math. All right, so then any questions on that part? All right, so then there's one type of a question in this objective that you might see on your homework. And I think that was what, number 11? Yeah, so number 12. If I tell you that log base b of 2 is approximately 0.356, log base b of 3 is approximately 0.565, and log base b of 5 is approximately 0.827. Find log base b of 12. This is a great ACT question. If you have not, or you like to retake it again, you might have seen this question before. Whenever you're ready to start studying, the study material for SAT, ACT, and TSI has all come in. So if you need to stop by, I have the material. We can start going over it. It'll be a book that you can keep. Just stop by, let me know. I will have no idea. That's a pedagogue question. All right, so the way you want to do this is notice all the values that I have is 2, 3, and 5. So I need to turn 12 into multiples of 2, 3, and 5. How can I break 12 down? 3 and 4, cool, but I don't have a 4, so what does 4 break into? 4, 2, and 2. So I can return this guy into log base b of 3 times 2 times 2, right? Or you could have also seen it as well as 2 squared, but it doesn't matter to me. All right, so now that you have this, if I needed to expand this, what does multiplication mean? Plus, so this is log base b of 3 plus log base b of 2 plus log base b of 2. Now that you have this written out, all you got to do now is just plug in all of those decimals and then use your calculator to get an answer. So I guess this technically would be approximately, but this would be 0.565 plus 0.356 plus 0.356. And what do you get? Yeah, so the hard part is just taking this and you want to break it down into the multiples of the numbers that you're given. So even though it's 3 and 4, I don't have a 4, but I can turn 4 into either 2 squared or 2 times 2. Both of them will give you the same result. Because even if you use 2 squared, this would just be 2 times 0.356, which is the same concept as 3.56 plus itself again. All right? So what we got? Headache. Where's the confusion? Just a headache in general. Gotcha. What was it? 1.277. So we're good there on a question like that on the homework. That's it. That's your answer. All right. There's one more type. The question came up on Thursday. Jamie, I think you might have asked it. What happens if the base is not 10? How do you find it in the calculator? Okay, let's talk about that. This is called the change of base formula. So change of base formula. And it is, if you have something like this, log base b of x, and that b is not 10, so I can't just plug it into my calculator, I can actually rewrite this as log base A of X over log base A of B. Now you might be asking, well, now I have another base of A, which might not be 10, but that's not entirely true. When you want to rewrite this, make A your base of 10. So instead of writing it like this, just write it as log of X over log of 10 and make those A's equal to 10. Because you get to choose whatever your base wants to be. Those are A's, yeah, not nines or N's or threes or anything like that. Maybe a U in there. They're A's. So, but let that base can be anything you want. Well, your calculator is very limited because you have a 4-function calculator there. Make it base 10 to make it real easy to plug in. All right. And again, you get to choose whatever your number. So if I wanted you to do this, this is a objective 4, by the way. So apply the change of base formula. We go through that every day. It's they're being too loud. Sometimes it's a vibration. So I don't know. Yep, very interesting. All right, so if I wanted you to figure this one out, we would say log base 8 of 5. This is number, I don't know, 13. I don't know what question number we're on anymore. All right, but on your test, or sorry, on your homework, that first part of the question is going to ask you what number is it between. We could go through the properties of figuring that out, but it's a lot easier just to figure out what the number is, and then you can know what number it's between. So if I wanted to rewrite this using the log base formula, how could I rewrite this? Giving you a minute. It is an 8. Be a good thing I didn't handwrite those tests. We'd really be confused. Yes. I have to give various credit depending on what you saw. How would I rewrite this so I'm able to type this into the calculator and actually get an answer? Are you hot? Because I was freezing cold when I first walked in here. I can only go down to 70. All right, so how can I rewrite this using that change of base formula? It would be log of 5. So you want to take that, what's the log of, over the original base, which is log of 8. Now I can easily plug this into the calculator, which again, the log button is right below the second. Got to turn it on first. But then log of 5. Huh? That's an A. Oh, I put a 10. Oh my goodness. Why didn't y'all say something? Look, if y'all are confused, y'all got to ask questions. I'm sure it was an error on my part. All right. It was a B. Sorry, B. So log base 5 over log base 8. And I think they're going to want you to round to 4 decimal places. So again, what you can do, you type in the log, make sure you close the parentheses, then you can divide, put another log 8. You don't necessarily have to close that parentheses if you don't want to, but then what do you get? I will wait. Oh, did it go away? These are the ones that have the solar thing. So if we take them outside, they can recharge. You don't see those very often anymore. Round to 4 decimals for me. What is it? Good. Don't forget, if you're asked to round to 4 decimals, even though it's a 0, you must write the 0. All right, that's a significant number. I don't know if you remember that from science, but that is a significant number. All right, and that's it. That's all I got. So any questions then on 1 or 4.4? Condensing and expanding, that's it. So let's go into 4.5, which is now using those properties to help us solve for x. Yes, ma'am. Go ahead. One more time. Oh, yes. So you'll turn your calculator on. Their log button is right below the second button. So you'll just put log, type in the 5. Make sure you close it, then divide log again, 8. You don't have to worry about closing if you don't want to, and then hit enter. There's only one word problem. It's really application of solving equations. So it's not so bad. I know, right? Oh man, I remember that being as a student when the professor would say, "All right, let's do this in application." No, why? That's what engineers do. All right, so section 4.5. What was the question up there? Oh, you're trying to write them up there? I'll rewrite it. Exponential. I don't take off for spelling. This isn't English class. Spelling isn't really necessary in the real world, anyways. Just kidding. Just kidding. Exponential and logarithm. Or so logarithmic, I guess. That's a G. It didn't. How did I spell it wrong? That's an A. It's an A. It's definitely an A. It is. They're both A's. Well, because one's logarithms, one's logarithmic. Yes, those are A's. Mic is IC. Logarithms is MS. Y'all not learn that in English or suffixes or whatever? We passed that. I passed it too. Way back in the day. Applications. All right. So okay. So exponentials and logarithmic. Sorry for this. I don't know how to get rid of it. But that spells equations and applications. Guess if it's an A or an O. It's totally up to you. Use your phonics. Applications. You can guess if it's an O. I don't care anymore. Alrighty, so basically this is just a whole bunch of solving. So let's go get right into it. There's no properties that we really need to get into that aren't too common sense based. Okay, so let's get right into it. So objective 1. There's only 3 objectives. Huh? Alongside, no? It's just a lot of solving, just different types of solving that you can use. All right, so solve exponential equations. I wouldn't. Just at this point in my notes, it's EXP. I wouldn't even spell the rest of it out. Just my honest opinion. All right, we're just going to, again, just solve. So let's look at one like this. If I have something like 5, yeah, mechanical, not so good. Okay. 5 raised to the 2z plus 2 equals 625. I said z. That's fine. Put a rubber duck. It doesn't matter what the variable is. You're solving for the rubber duck. All right. So 2 raised to the z. If I'm doing normal z, it looks like a 2. And you're going to be like, is that 2 times 2? So 5 raised to the 2 times z, or duck, whatever you want to draw, plus 2 equals 625. Yes, this is the way you want to do it. To manipulate this problem, you want the basis to be the same. You can't break down 5 anymore, but what does 625 turn into? 5 times how many? Right, because 5 times 5 is 25, times 5 is 125, times 5 again would then be 625. So I can rewrite this. It's probably the same way. I mean, it's rogue memory. I mean, 125, add it 5 times gives you 625. But the goal is you want the base to be 5. So just throw 5 times 5 until you get to 625 or whatever number you're trying to get to. All right. The goal is for those bases to be the same, because if the bases are the same, what can I say about the exponents then? They should be the same for it to be equal. So now I can get rid of the base entirely and write it as 2z plus 2 equals 4. The 5 goes away because the exponents have to be the same. So the 5, so technically, if you want to look at this in a mathematical way, you could apply log to it, and I'll show you what the log rule is. But if these two things are equal to each other and the bases are the same, that means that the exponents have to equal. Right? And then that means that I just got to solve for this. How would I solve this? Minus 2, so I get 2z divide by 2, so I get z equals 1. I guess Christmas time, right? All right, so that was number 1. Let's do another one. Doesn't the sleigh also have an EIH? Yeah, like you sleigh. Oh, I got you. All right, number 2, let's do this one. I'll give you a chance to do it at least. 7 raised to the 2x minus 3 equals 1 to the 49th raised to the x plus 1. Are we cold now? I called this. Okay, I like where you're thinking. Yeah, it has to be because it's a fraction. But remember what you're trying to get your base to be. Yes, perfect. So 49, we know 49 is what rewritten? 7 squared, right? And since it's on the bottom, I can bring it to the top and I can write it as 2x minus 3. Yes, ma'am? Yes, if it's a fraction, it becomes a negative power. And since it was 49 and I want my bases to be the same, I know it's going to be to the square, but because it's a fraction, it becomes -2 instead of just a regular 2. Very good, because a power raised to a power means what? Multiplication. So I get 7 2x minus 3 equals 7 to the -2x minus 2. Right, because you would have to take that -2 and distribute it. You have to multiply it. And since the bases are the same, what's that tell me about the exponents? They have to be the same as well. So now I have 2x minus 3 equals -2x minus 2. How do I solve? Sounds good. Add 2x. Doesn't matter which way you go. I like to stay away from negatives. And you can go ahead and drop out another step and go ahead and add 3 to the other side, because you know you're going to remove the constant. If you want to write those into 2 separate steps, that's completely fine. I don't mind. But that will go away. That will go away. I now have 4x equals what? 1. Last step, divide. So x equals 1/4. Questions? Was it too quick? Okay. Waiting. Soak it in. Marinate a little bit. Develop any questions? Math marinade. It's pretty spicy. Me too. I love frying it. It's the funnest part. I don't even care about eating. It's just I just want to fry it. Like an air fryer, but like a big one. Oh, you've done it too? Okay. I've always wanted to smoke it. I just get worried about drying it out. Mm. Do you have to buy a machine for that, or yeah, like a big old air fryer? Hmm. It's gonna be worth getting. Alrighty. So let's get right back into it now that we're all hungry, getting ready for lunch. That is a z. That's 2 to the z equals 70. Here's my question to you. Can you manipulate 70 so it has a base of 2? No. What happens now? How do we solve this if we can't manipulate it? We have to do it. So this is what I like to call the log rule. I don't really know what the actual property or rule is here, but you can actually take the log or natural log, whatever you like better, of both sides. What do you prefer, log or natural log? Log. Sounds good. So what I'm going to do, as long as I do it to one side, I have to do it to the other. I can rewrite this as log of 2 raised to the z equals log of 70. If you're going to use log, keep it base 10, keep it simple, so you can plug it into the calculator and everything. If you're going to use natural log, just know you have a button for that, or it's log base e, however you want to write it into the calculator. So using our properties, what do we know that z now turns into? Good, it becomes the coefficient. So now it's z log of 2 equals log of 70. How would you solve for z now? What's the question? Nope. Divide. If it's being multiplied, I got you. I got you. So this is going to be log base 70 over log base 2. Now I want to caution you real quick. Let me divide it. I want to caution you. You cannot do 70 divided by 2. Okay? That does not work here. You can also not do 70 minus 2, thinking you're condensing it. That's improper logarithms. You plug it in just like that. Log with the base of 10 of 70 divided by log of base 2, or sorry, of 2. Because it doesn't have the same properties of like square roots. I can't just put it in one logarithm. Because if you remember, if I'm combining and condensing, if I'm dividing, I can subtract, but that would be dividing inside the same fraction. These are not in the same fraction, so I cannot make it subtraction. So therefore, I have to type it in the calculator like this. And if you round to 4 decimal places, what do we get? Okay, whatever. All right, it's whatever you want it to be. All right, so let's do another one. I'm going to have to go see somebody. All right, try this one. So this is now 10 raised to the 5 plus 8x plus 4,200. Oh, thank you. Oh, it's dying. Hopefully it can make it to the rest of the day, or the period. No, but just continue writing without a recording for it, because I can only do with what my battery gets. That's an 8 right there. Not a gamma. That's exactly what you do. Before you can apply a logarithm, you need to isolate where your exponent thing is. So I'm going to go ahead and subtract 4,200. So that's going to give me 10 raised to the 5 plus 8x. What's that going to be? 80, 79, 8? Yes. 79,800. Because you subtract straight 4,000, you're at 8,000. Subtract 200 more. So you had 8 million or 42,000. I got you. 4,200 is what the number was. All right. Now what would you do? Log. Some cool things are about to happen. Log of 10 of 5 plus 8x equals log of 79,800, real small number. What do we know about that exponent? Okay. What does the exponent turn into? A coefficient. But then what do we know log of 10 is? 1. Because remember, if the base, which is imaginary, and the log it's taking of is just going to be 1. So this ends up being 1 times all this. So it's really 5 plus 8x. One more time. Oh, you mean leave it like 1 raised to that? That's not necessary. You have to apply all the properties. So this exponent becomes the coefficient, then it becomes 1. If you also remember that property, if it was log b of b to the x power, the answer was just the x. Yeah, so you could go straight there. Yes, that I was just showing you everything that happened there. That's a very good question. How would I finish off writing this problem before I go ahead and type it in? Now, I can't divide yet. What would I do first? Subtract by 5. So this gives you 8x equals log of 79,800 minus 5. Do not subtract 5 from that big number. This is a log. This is a constant. Divide it. Oh, well, skip the step. Divide it by 8. Yeah, so that would technically be the answer, but I'm sure it's going to want a decimal. I will tell you this. When it comes to my test, I prefer you to keep it like this. So I will tell you to not round. I'll tell you to give me the exact answer so you can stop here. You could have stopped over there at log 70 over log of 2. I want you to give me the exact. Your homework might want you to round, so I want you to practice using your calculator. For my test, yeah, you stop there because I'm always about exact. Remember, I'm a mathematician, not an engineer. Mathematicians want the actual answers. Engineers just go, 7. So that's the debate between engineers and mathematicians. Yeah. If you know anything about engineers, they go, oh, this can work. And then an architect draws it up. And then an actual person that has to actually make the building's like, this is not possible. Like, yeah, this is a dream world. It's like Minecraft. Things have to be structured right. But those are life lessons that you'll learn. All right, so what did I get? I actually don't know it. So I would do the log first, then subtract the 5, then divide the answer by 8. Don't ever try to type everything in at once. So mine's a negative as well. I got negative 0.0122. If you did it all together, you got to make sure you close that parentheses. That's the result you should have got. Negative 0.0122. Anyone not get that result? You didn't get it? Again, I would do it in waves, especially with these 4-function calculators. They don't work like them TSI. Figure out the log is first, subtract 5 from that answer, then divide that answer by 8. There you go. That'll help you with any errors you might get. But remember, you can just hit the function. Don't try to type the decimal in. You can, after you do log of 79,800, just hit the minus sign, take the answer so you don't have any rounding errors. So don't try to write those decimals out. Yes. So what number was that? Okay, let's do number 5. If you go to the bathroom, you might miss something important. So this is 80 equals 320 e to the negative 0.5 t. I just want to point something out. That's a nice looking e. So I'm just saying. Yeah, I want to call the rest of it bad, but that's a T. The T. You can put a J, you can put a fish. the letter you're looking for. Is E, though, a variable? No. It's a number. It's 2.71. The T, the fish, the J, whatever you want to make it as, that's the variable you're looking for. Yes. What does that look like? A 3? It's going to be a lot of stuff. Okay. All right. We do this right here. We see this. We go, there's no way to manipulate these two numbers to make them the same. So I'm going to try to get it to a point so that I can figure out and isolate that exponent. I see an E. What logarithm am I thinking of right now? The natural log. But I can't just take the natural log to get rid of that E because of that 320. What should I do to get rid of that 320? Divide by 320. So now I get 80 over 320. Yes. That can be simplified even further. 8. Right? Oh, you're right. 1 over 4, 1/4. Yeah. The E didn't turn out as good. It's fine. Yeah. You're welcome. All right. So now that I have that E kind of isolated, now I'm going to want to take the natural log. And here's the reason why you would want to take the natural log. You might already know. Because the base of natural log is what? E. So all of this will turn into a what? A 1, and the exponent will then just drop down. So now I get the natural log of 1/4 equals negative 0.5 t. Makes your life a little bit easier. Negative. So then what do I do next? Very good. So I get the natural log of 1/4 over negative 0.5 equals to t. So again, on the test, I would ask you just to stop there. On your homework, you might have to go further. Am I boring you, Jamie? I don't know. Whenever the bell rings now. What do we get? I agree. So again, you want to do natural log, which is the button underneath the log button. And then just type in 1/4. You could turn it into 0.25 if you would like. That's what I did. I did 1 divided by 4. Yes, because I think that's what the homework's going to ask for is 4 decimals. But on the test, I would want you to stop at natural log of 1/4. And like I said, in the directions, I'll tell you, I want the exact answer.
Oh, we had so much fun having you, Bob.
Okay. What'd you just do? You grabbed your thumb like the calculator had just cut you. I was like, sharp objects that happened after class was over, so that doesn't fall on mine. All right, so any questions on that one? Y'all did really good. Thank y'all. Yeah. You bullied me during an observation. I guess I can't complain. I'm changing colors. I'm tired of looking at pink. All right, try this one. I think we're on number 5. I don't remember. Number 6? Seriously? You sure right. Today we get out. Yeah. So that's a number 6. I feel like erasing. 11 minus. So 11 raised to the 1 minus 8x equals 9 raised to the 2x plus 3. Ooh, man, this is about to be a fun one. Please tell me I'm wrong. Please tell me I'm wrong. Please tell me I'm wrong. Nope, definitely ugly. Cool. You ready? All right. No way to manipulate 11 and 9 to make it the same base, right? So then I'm going to do what to it? Multiply by what? How would you do that? Whatever you do one side, you got to do the exact same thing to the other. 11's prime, 9 turns into 3 squared, so you can't go any weirder or different than that. So let's go ahead and let's take the log of it all. So let's take log. Be ready. Y'all got plenty of room on this one? Gonna need at least about 5, maybe 6 lines. You can. When you rewrite it, go ahead. All right, so there we're at. Now, I can't just simply divide by log and get my x by itself, because what happens? I have an x on both sides. So what I'm going to have to do is actually take this logarithm and distribute it in there so that I can try to get my x's to one side and my non-x's to the other side. So this is what I mean by that. Take your log base 11, distribute it out. So this becomes a log base 11 minus 8x log base 11. I recommend you write the log second, just because that's an L. I don't know why I wrote a 1. What's 1 times anything? You can put the 1 if you would like. But again, it's just nice to put the logs. What's the question? Yes. Huh? Times 8x. Yeah, so this is 8x times log 11. Technically negative. Yeah, I can't put this inside the logarithm. This is like saying the square root of 11 times 8x. So it'd be 8x square root of 11, or however you want to write it. I think it looks cleaner this way. Some mathematicians would take the x and put it in the front, but in my opinion, then that looks like the x is in the logarithm and it becomes real complicated. Yes, ma'am. So this becomes 2x log of 9 plus 3 log of 9. Now at this point, what I want to do is anything that has an x, I want to bring it to one side. Anything doesn't have an x, I want to take it to the other side. I personally would. I hate dealing with negatives. So I'm going to move my x this way and my non-x this way. But you could move this x here and the non-x there. Both ways will get you the same answer. Okay, so that's what I'm going to do. I'm going to add 8x over and subtract 3 log 9 over. So I now get log of 11 minus 3 log of 9, that's an 8, of 9 equals 2x log of 9 plus 8x log of 11. Y'all still with me? Okay. Yes, ma'am. Oh, we'll definitely continue this tomorrow, and then we'll be almost done. Yeah, we're almost done. We're almost on objective 2, and then objective 3 only has 1 question.